So let us take an example to see that how we apply this momentum principle to calculate the forces. So in this case, this is problem from the textbook. This is chapter 6 of the textbook. Find the horizontal thrust of water on each meter width of the sluice gate. So now we consider a sluice gate, and we are interested to calculate the force on each meter of this gate. Clear? This each meter means that width. So width is perpendicular here. Width is perpendicular to this slide. Clear? So per unit width, how much force is acting, that we need to calculate. So we are given y1 is equal to 2.2 meter. This is y1, 2.2 meter. y2 is 0.4 meter. This is 0.4 meter here, y2. And y3, that is the depth of water under the gate, that is 0.5 meter. Now in the question it is stated that neglect the friction. So we have to neglect the friction. Now how to solve this problem? Let small q be the flow rate per meter of width. It is cubic meter per second per meter. This is already we studied before. This q, you have q the total discharge. Clear? That is cubic meter per second. That is cubic meter per second. If I divide this volume per second, now if I divide this by length or width, clear, perpendicular to the board, because this will be a gate, it will continue like this. This gate will continue like this and retain the fluid. Clear? So it has the width. So the width you denote by L or B, whatever you take it, then this will be equal to discharge per unit width, and it has the units of what? Cubic meter per second per meter. So that's why it is stated that you only calculate the force of water on each meter width of the sluice gate. Now from continuity, so what we have continuity, Q is equal to V1 Y1 into V2 Y2. So now unit width is considered. So that's why we only consider the depth here, Y1 here and Y2 here, because the width is coming here, divide Q divided by B. So that's why we have discharge per unit width. Clear? So now from here, so V1 will be equal to Q divided by Y1. Y1 is what? 2.2 meter here. And V2 is equal to Q divided by 0.4. Y2 is 0.4. Clear? Now we apply the energy equation, but we neglect the friction. Clear? So in that case, what will be the continuity equation in that case? That will be equal to Y1. This will be equal to Y1, and this will be equal to V1 square divided by 2G. We consider the datum as same, so that's why we do not include. That will be equal to Y2 plus V2 square divided by 2G. This is now the continuity equation. This is at section 1 here. This is section 1, and in here you consider section 2. So this is the continuity equation. Now here just put the values. So 2.2 V1. V1 is Q divided by 2.2. Similarly, Y2 is 0.4, and V2 is Q divided by 0.4 whole square. So V square divided by 2G. Now from here, the only unknown is Q. So you can calculate Q, the discharge per unit width. Clear? Once the discharge is known, then you can calculate V1 and V2. Then we can calculate V1 and V2. Now we consider summation of forces acting. Clear? So now in this case, what are the forces which are acting? So one is due to the depth of water here. If I consider the depth of water here, so you already know that there will be, this will be the pressure distribution diagram here, and there will be a resultant force acting here. So let's say this is your F1. Similarly, for this case, there will be a force for in here. So that's why there will be a force here. Let's say this force, that is F2. And in the equation, as I said before, that this summation of F, this represents the external forces on the fluid. Clear? So this actually represents the external forces on the fluid. Remember, these are the external forces. So external forces on the fluid means that this will be actually the force of gate on the fluid. So we can assume that in this direction. Let us assume that it is in this direction. And this will be force Fx. This will be force Fx, or you can also write down this will be the force of gate on water. Force of gate on water. We assume this to be acting in this direction, towards the left. Clear? In the end, the sign will tell us that this assumed direction is correct or not. So let us assume, we assume that this direction it is acting. This is, remember, assumed direction. We don't know. Only in the end. So this direction here, this is assumed direction. This is assumed direction. So now we say that, let's say in this direction the forces are positive. F in this direction is positive. So we write down F1 minus F2 minus Fx is equal to the rate of change of momentum. This is the momentum equation. Clear? Summation of forces is equal to the rate of change of momentum. Remember, these are the external forces. Now you can plug in the values. So these forces, we can calculate F1 and F2. How we can calculate this F1 and F2? We already know that this dimension here, you already know from geotechnical engineering as well as from fluid mechanics, that this is equal to gamma into Y1. Gamma into Y1. Clear? Just like you remember that in case of hydrostatic pressure distribution diagram here, you see that if this is H, then this will be equal to what? This will be equal to gamma H. Clear? So this is equal to gamma Y1. And now we also have Y1 here. So what will be this force? It will be the area of this. Clear? It will be the area of this. And what is area of this triangle? So the area will be equal to half of base into perpendicular. This is Y1 into gamma into Y1. So this will be equal to Y1 gamma Y1 square divided by 2. This is what is written, gamma into Y1 square by 2. So this is the force. This is the force, F1. Similarly, you will have F2. Clear? So this is how we calculate the force. Similarly, this force that you calculate, you have another formula, F is equal to gamma HC into A, where HC is the centroid of the area. Clear? So then in that case, if you want to calculate the same force F1, so what will be that? Gamma remains as gamma. What is HC? HC is for the area. So for this area, what we have? This is the area that on which it is acting, the unit width. This is the area. Clear? So we have this as Y1, and the unit width that we consider, that is 1, because it is acting perpendicular to this one. Clear? So what is the centroid here? Centroid of this area, a rectangular area here, the centroid will be equal to Y1 by 2 for the area. Clear? Rectangular area on which it is acting. Unit width. So this is 1 meter, as it is stated here. Each meter width of the sluice gate. So now for this, it is Y1 by 2. So HC is Y1 by 2. And then what is area? Area will be equal to Y1. What is the area here? Y1 into 1. So from here, what is F1? F1 is equal to gamma Y1 square divided by 2. We use the same equation that we just developed here. So you can see here you get the same expression for the force. So now F1 is equal to this, F2 is equal to this, Fx we need to calculate, rho is 1000 kilogram per cubic meter, Q we already calculated here, and we already know the velocities here. We already calculated velocity v1 and v2 and q. So that you can put here, from here the only unknown is this f. So now we can calculate this f. So f is 11,000 Newton per meter, and we get plus sign here. So it means that this assumed direction is correct. We assume it to act to the left. So it means you get positive sign. It means that the assumed direction is correct. So this is the force of the gate acting on this water. But we are asked to calculate the force of water on the gate. So equal and opposite is the force of water on gate. The force of water on the gate, that will be equal to 11 kilonewton, and that will act to the right. So it means that equal and opposite, that will be the force of water on this gate. So this is how we apply the momentum equation to calculate the force of fluids on these structures. And this is only possible by application of the momentum principle.
सर ये F1 और F2 भी external force में आते हैं?
F1 and F2, these are the forces acting on this gate. Clear? These are summation of all the forces which are acting. So this Fx, this is acting on this gate. Clear? This force which is acting, actually you want to calculate this force here. You want to calculate this force. What is the force of water that is acting on the gate? Clear? The thing is that when we apply this equation here, this gives sum of all the external forces. If I go back, what you have written here, this is the summation of all the forces acting on the fluid mass. Clear? In the control volume here included the gravity forces, the shear forces, and the pressure forces, including those exerted by fluid surrounding the fluid mass under consideration, as well as the pressure force exerted by the solid boundaries in contact with the fluid mass. So here everything is given here in this case. Clear? So what we do here is that this force that we calculate here, this Fx, this is the external force. This is the external force that you can calculate here. What is the force of gate on the water? So this equation, when you apply, this will give you the external force. Clear? Then we say that the force of fluid on the structure, that is equal and opposite to that. But this force that you calculate, we have to consider these forces here, F1 and F2. Clear? Because these are the hydrostatic forces, and these you have to consider, because if you do not consider these forces, how you can accurately calculate this force? Because there is effect of these forces here. You want to calculate this Fx. So Fx will be equal to this minus this rate of change of momentum. So that's why when we calculate the forces for any case, this will give us the external force that will be acting on this fluid. And then the force of the fluid on any structure, that will be equal and opposite. We will just say that this Fx, this will be equal to force of water on gate with same value, but this was acting to the left, this is acting to the right. I hope now your question is clear. Next we
Yes sir, thank you.
Next we consider force on pressure conduits. We continue with applications of that. You can apply this. This is just one example that I took from our textbook. Now you can apply this momentum equation to calculate the forces on spillways, because let's say on the spillway the water flows. This is, let's say, a spillway, and then the water flows over this spillway, and you are interested to calculate how much force is exerting this water on this spillway. You can apply the same concept and you can calculate this. So all the hydraulic structures that retain the water, you can calculate the forces by application of this momentum principle. So I consider just one case for understanding that how we apply this momentum principle. You can, as a practice, consider many cases and then apply the momentum equation and calculate these forces. So we consider an example to understand how to calculate the force of a jet on a stationary vane or blade. So we consider this example. This is now a stationary vein, it is not moving, and we consider that the fluid is flowing over this vein, velocity v1 and then velocity v2, clear, because as the fluid flows due to the friction losses, the velocity is reduced to v2, clear, and the velocity leaves, the fluid leaves with the velocity v2 at an angle theta. So now it says that the free jet of water with initial diameter of 2 inch, the diameter cross-sectional area of the jet of water is 2 inch, it strikes the vein as shown in this figure. Theta is 30 degree, v1 is 100 foot per second, and due to friction the velocity of the fluid leaving the vein, that is 95 foot per second. So flow occurs in a horizontal plane. It means that we can neglect weight of the fluid. Find the resultant force on the vein or this blade. Now we want to calculate the resultant force, which is acting on this, clear? So the forces Fx and Fy represent the component. Directions are assumed. So this direction and this direction, these are assumed. We don't know. In the end, their plus minus sign will tell us that these assumed directions are correct or not. So this is always the case. We have to assume the direction of our forces and then do the analysis, and then in the end, after we simplify the momentum equation, their sign will tell us that the assumed direction is correct or not. If we get plus sign, the assumed direction is correct. If we get negative sign for the force, it means that the assumed direction is incorrect, reverse the direction, clear? So that's why we will assume the directions. So the net force that we can calculate on the x and y directions, and then the total force by using Pythagoras theorem. So in the x direction, we have summation of Fx is equal to rho q into delta v, change of velocity in the x direction. First we need to calculate area because we have to put the values for these. So area is 2 inch. The diameter of the jet is 2 inch. So the area you can easily calculate, pi by 4 into d square. Now we have this expression here. So we do not have any other forces in this case. So we just assume that minus Fx in this direction is equal to rho q into v2x minus v1x, means the change of velocity in the x direction, clear? See, we do not have now other forces. So only we consider this Fx, clear? Previously we had the forces. Now we consider only these two forces here, Fx and Fy, because here you see, if I go back, so here you see the fluid flows under pressure here. It is a pressure conduits. So that's why we consider P1 into A1. Now in here it is a free jet. So the pressure is atmospheric pressure, clear? Pressure here is atmospheric pressure, free jet of water. So that's why the only force we consider here is this Fx. There is no other forces, clear? So now we just put the values. Again, this V2 you have to resolve into components. So this is your V2 and it makes an angle. This will be the two components here. This makes an angle theta. This will be V2 cos of theta. And this will be V2 sine of theta. So that's why the change of velocity that will be equal to, in the x direction, V2 cos of theta minus V1. So when you simplify from here, we get this answer, F is equal to, now we get plus sign for this F. When we get plus sign for this F, it means that this assumed direction is correct. Similarly, see, the plus sign indicates that the assumed direction of Fx was correct. Then we consider summation of forces in the vertical direction, y direction. So then in that case, plus Fy, because it is in the plus y direction, this is plus y here, so this is in the plus y direction, plus Fy, rho q into change of velocity in the y direction. So in that case, in the y direction it has no component, so that's why it is 0. And what is the component of V2 in the y direction? Here, V2 sine of theta, clear? So that's why Fy is equal to 201 pounds. Again we get plus sign, it means that the assumed direction for this Fy is correct. If we get negative answer for force here, then it means the assumed direction will be incorrect.
सर यहाँ लिखा है flow occurs in a horizontal plane.
Yes. So
तो
you
सर
have
हमने
this.
जी
Yes, yes. What is your question?
सर जब हमने फोर्सेस एक्स डायरेक्शन में फाइंड किया तो आपने कहा कि मास ऑफ द फ्लूइड शैल बी वेट ऑफ द फ्लूइड शैल बी नेगलेक्टेड।
Yes.
तो अब तो आप फोर्सेस इन वाई डायरेक्शन में फाइंड कर रहे हैं, तो यहाँ हमें वेट ऑफ फ्लूइड ऐड नहीं करना पड़ेगा?
Okay, so this is horizontal plane. It's not vertical plane. This is the problem. Try to understand. This is horizontal x-axis. This is horizontal y-axis. It does not mean this is y plane. This is now horizontal plane here. This is horizontal plane. This is horizontal plane. So this is your y, and this is your x. This is your x, and this is your y. And perpendicular to this, above or below, if I go perpendicular to this, that will be your z. Then in that case, you need to consider weight of the fluid. Now, is this clear or not?
Yes sir, clear.
So that's why it is stated that flow occur in a horizontal plane. This y does not mean that this is vertical. It is a horizontal xy. Clear? So now we calculated the two forces, Fx and Fy. We can apply the Pythagoras theorem to calculate the resultant force. So the resultant force will be just square root of summation of the square of the two forces. So here this is the total resultant force, and we can calculate its orientation. So alpha will be equal to tan inverse the two forces. Alpha is this. Now this is the external force. So the force of the fluid on the blade is equal and opposite to this. It means that the force of the fluid on this blade will be equal and opposite to this. This will be the force of the fluid or water. Clear? Fluid or water on this blade or vein, whatever you write down. This will be equal and opposite. This will be for the x and y forces. The force of the fluid on the band, it will be equal and opposite to this, and at an angle of 69.5 degree, this one here. Clear?